Okay, can everybody see, can you, oops, don't do that, Hubert, whatever you do, don't do that. Okay, Easley and Pendleton, can you see my graph on the screen? Just want to make sure everybody can see it. Okay, all right, of course, on y'all's screen, it's going a little bit slower, but on this screen, it's going like real time, but it's a little bit slower because with all the streaming, it goes a little bit slower. But anyway, I foresee us finishing up the algebra and logarithmic and limit review. I see us finishing that probably next Tuesday. Okay? So that means that Tuesday we will probably be pulling up the test and looking at it, or a test like it, and our pretest, what do you want to call it? The reason I'm going to pull it up, a pretest or one like the unit test, is because I want you to see the format of WebAssign. Since some of you have never had WebAssign, it's a little bit different than MyLabs Plus. So I thought I would make a pretest and pull it up to let you look at it. I just put this on the screen because this is what I was showing you the other day. This is what happens when you actually put the algebra with the limit theory. You get the green line converging onto the tangent line. Now, a lot of you say, well, what good? We're in business. We're not in graphics. Well, that black line represents rate of change. It represents the slope. And that is very important when you're talking about profit. Very important when you're talking about a point on a line in a marketing class or a business class. So, or not a business class, but in a business setting or a marketing setting. Accounting also. So, just a little bit of what we gave you yesterday. You see what's happening here. Hold on a second. This right here, called the squeeze theorem, when you actually converge on X, what's happening on Y? It's convergence. And when you get both convergence, you get the secant line turning into the tangent line. Now, at this point, right here, you're talking about the width of a hair divided into 1,000,000 times. So you're talking about barely right beside that, and you got to think out of the box. And that's where people, they go off the road. They're on the algebraic road, and they're thinking in the box. And then when they think out of the box with the calculus, with the limit theory, and they're taking half of a step and a half of a step and a half of a step, will you ever reach the wall? That's where they go off the road, and they don't understand calculus. So if you've got some indication of what this is doing, then you're going to understand the calculus and finding the first and second derivative. The first derivative will also show us the inflection points on a polynomial that's above the quadratic. In other words, a third term polynomial or a fourth or fifth term polynomial. So that's where we're heading. And I'm going to finish up today with, or not finish up today, but today and Tuesday with the questions that we've continued to go over. And I've got questions from different sections and different people. So I'm just going to pick some sections. 1.8, let's see. I don't want to spend a lot of time on repetitive. We've already done that. So I'm not going to do a lot of repetitive problems. And I have to hit this thing, and I'm sorry, but I have to hit this thing every time, and that's WebAssign's fault. It's not mine. 1.7, evaluate the function. Okay, y'all know how to plug and chug. That's pretty self-explanatory. We went over that the other day. So some of these are questions that we've already covered within somebody else's questions or the same questions over and over. So I'm just going to go to the important questions. If I see a completing square, we're going to do that. So let's go ahead and move to that one. All right, let's look at that one, and if you can't see it, make sure that your screens are maximized on my screen. So let's go ahead and do this one. And this is W squared equals 8 times W minus 3. Yeah, just come on in whenever, that's fine. How was breakfast? Was it good? Oh, well, you should have. You're late. You know, I'm just kidding. All right, so W squared equals 8W minus 24. And we set it up square. You can set it up for reverse FOIL, but what's the problem with that? Sometimes these things are not what? Factorable, okay? Thanks for the interaction, whoever said that, I appreciate it. W squared minus 8W plus 24 is equal to 0. Set it up in quadratic form, and then bring the 24 back over. You don't have to do that. I just do it to show you quadratic form. Minus 8W plus blank is equal to negative 24 plus blank. And half of 8 is 4. 4 squared is what? 16. Now that's going to give you shortcut number 2, which is W minus 4. Quantity squared is equal to negative 8. What's the problem here? There's a problem. What is it? For some of you that remember completing the square and quadratics, what's the problem? Okay, I can't hear you.
Imaginary numbers.
Okay, imaginary numbers, she said. Is that correct? Okay, everybody say yes or no. Just pick one. It's 50-50 shot.
Yep.
Okay, good job. Yeah. All right. You got imaginary numbers? Somebody tell me what my vertex is. And enunciate and volume. Remember? Enunciate and volume. What's my vertex?
4, negative 8.
4 and what? Not negative 8, but positive 8.
Positive
so that's
8?
our vertex. All right, now, solve it. Now, let me go ahead and tell you. Sometimes you're going to have teachers that want you to say no x-intercepts. Sometimes you're going to have teachers that want you to put it in form of I. So the best thing for you to be able to do is to make sure you can put it in form of I. So, also, remember this. When you take the square root of both sides, at this point, you should say to yourself, there is no x-intercepts. I want you to highlight what's under the radical. Now, what's under the radical is called the what? Starts with R, radicand. But when it's in a quadratic setting with completing the square and you're talking about x-intercept, it's called the discriminant. Okay? The discriminant tells you one of 3 things. The discriminant tells you whether it is a floating parabola. So if you've got a square root of a negative, then that tells you that you've got a floating parabola, which means it has no what? Has no x-intercepts. And it could be down on the bottom also. A lot of people don't understand what I means, and that's why I'm showing it to you. If square root of a positive, you've got 2 x-intercepts, meaning that it crosses what? The x-axis. Square root of 0 means that it's what? Sitting on the x-axis, and how many intercepts do you have?
1 at the vertex.
So the discriminant tells you 3 different things. It tells you which one is it most of the time. Most of the time, it's this one. Okay? Most of the time, you're going to come out with the square root of a 6 or a square root of an 8 or whatever the case may be. Something else I'd like to, and you need to all write this down. Sometimes, and I'm just going to write this as an example. We'll write it in blue for an example. Sometimes you're going to have this. Negative 2 square root, I'm sorry. Negative 2 x plus 4 quantity squared equals negative 6. Vertex is negative 4, positive 6. Is there x-intercepts on this one? Okay, that would be no, that's not a rhetorical question. I'm asking for interaction here.
Yes.
Yes.
Yes, why? Anybody want to take a stab at it?
The parabola is facing downward.
Okay, well, yeah, it is. That's because of the negative. But why that negative 6? So we have a negative 8 on the right-hand side. Why is it different? I'm trying to get you to think about the next step.
Do you have to, is it because you divide out the negative 2?
What happens to the negative 6? It becomes what?
Positive.
It becomes positive. So yes, you do have x-intercepts because at this point, remember, what is in play right here? The radical. So you've already got it to that point. I haven't got it to the radical yet because I've got to do what? I've got to get rid of this negative 2. And when I do that, I get x plus 4 quantity squared is equal to 3. And now, I'm sorry, the vertex now is 4 and, oh no, it's, okay, it's 4, that's right. And here, I've got the square root of a positive, which tells us to what? X-intercepts, and it could be going this way also. Okay? Now, this you need to make a note of, because what's going to happen on you on a test or homework is you're going to sit there and you're going to say, that doesn't have x-intercepts. But it does because you're dividing by what? A negative. And that's going to always make this number positive. So be careful. There's two different types of negative products. There's the negative product that gets divided by a negative, and then there's the negative product that just stays a negative. And this is what you have to remember to turn into I. All right, so let's turn it into I, because I don't think we've done one in the review to where we turned it into an I, have we?
I don't think so.
I don't think so. So we've done a lot of them, but we haven't done one to turn into an I. So let's do that. Somebody give me the problem again. What is it? W what?
Do you want to start from the beginning?
No, where I circled down there, where the negative 8 is. W what?
W minus 4 square root of 8, and then negative 8.
Is that it right here? Is that it?
Yeah.
And then you just
Yeah.
put
Okay.
square root.
All right, so here we go. We know that the vertex is 4, 8. All right. Somebody tell me what the y-intercept was in the original when I put it in quadratic form. What is C? Was it 24 or negative 24?
Yeah.
So y-intercept is 0, negative 24. And now we're going to solve. And W minus 4 is equal to I'm sorry, I'm going to show you how to really do it. So I'm skipping a step and I don't need to do that. The square root of negative 1 times the square root of 8. All right, that's for those of you that haven't had the algebra in a while, and this is the first time we're doing the you have to break it up into the square root of negative 1. And remember, there's two things that you got to remember with I. Go back to 109. I is equal to square root of negative 1, and I squared is equal to what? Negative 1. You need to remember that. Okay? So you need to highlight that because that comes from. So back to our problem. That's going to be W minus 4 is equal to I square root of 4 square root of 2. W minus 4 is equal to I times 2 square root of 2. W minus 4. Oops, I'm not going to do that. I'm going to bring the 4 over. Sorry. W is equal to 2I times square root of 2 plus 4. You could factor out a 2, and basically this tells us that the parabola has no x-intercepts because of that guy right there. But some tests, some books, some homework wants you to put it in the form a plus bi. Now let me go ahead and tell you about that. Is addition commutative? Yes, it really doesn't matter whether you put the I first or the 4 first. But in some books, they say they want it in the form of a plus bi, which means you need to turn it around. 4 plus 2I square root of 2. Now me personally, since I've been teaching you that addition is commutative throughout your whole mathematical career, why do they change it? I mean, why do they say you have to write it in that? I don't. I say either answer is good, but there are some that want to throwing that out as a warning. If you ever get one wrong, that's probably why. Okay, does anybody have any questions so far on what I've done? Okay. Easily, you awful quiet. Where is
Yeah, we're good. We're just paying attention, man.
Oh, y'all just paying attention. Why'd you switch sides of the room?
It was uneven. There was 2 over there, 1 over here, or there was 3 over there, 1 over here. It was
You're not
messing with my
selling
brain.
drugs on the other side of the room, are you? I just want to make sure you're
I
not
was
trying to
lonely.
hide.
I'm sorry.
Okay.
You don't
Hey,
need to
y'all need
worry.
to watch that. Have
Hubert,
groups
I have
at
a
8
question.
o'clock every night. I mean, every week. All right. So here we go.
Hubert,
Yeah.
I have a question.
Yes, sir.
And you put a radical over -8, would it not become plus or minus square root of?
Yes,
you
but
know?
that is since the radical is still here, that is still there. As long as you have the radical, you don't have to put the plus or the minus because it's assumed to be there. When you take the square root, and you can put it there if you want to. If you want to put it here, you can. It doesn't take off because you can't add these two together. It really doesn't make a difference, but that's a good point. Usually when you use the positive or negative, square root of 9 is equal to positive or negative what?
3.
That's usually when you use it. But yes, you do have an argument. You can put it in front of the 2, but it's not wrong if you don't because the radical is still in there and you cannot add apples and oranges. You can't add the 4 plus the I. You can't add it. So it's kind of either way is okay. All right, but that's a good question. All right, 0 and -24 is way down here. And we got a vertex of 4. Okay, something's wrong. Why is something wrong? Oh, this one's not. Wait a minute. Okay, somebody check is that negative?
No, the y-intercept wasn't -24. It was 24.
It's positive 24, wasn't
And
it?
brought it back over.
Okay. Okay, and that's why you sketch it. Why do we sketch it? We sketch it to see if everything what?
Checks out.
Lines up. And I just caught that because, when we transferred it from the transparent board to the whiteboard, messed up. Okay, and 4 and 8, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Now, of course, my 0 and 24 is not correct. It's kind of out of scale. And of course, your domain is all real numbers. What's the range from 8 to what?
Infinity.
8 to infinity, good. What's decreasing?
From a negative infinity to 8.
Negative infinity to 8. And what's increasing?
8 to infinity.
And what's the line of symmetry?
8.
Not 8, but line of symmetry is always your x value of the vertex. Yes. Okay, who has a question on that one? Hopefully, it's starting to flow. Once you do completing the square about 10 times, once you do 5 or 10 problems, you either remember it or you've gotten better at it, one of the two. Capiche? Yeah, Hubert, I understand. Good. No, Hubert, I don't understand. Thank you for the interaction.
You weren't speaking English. We couldn't.
Oh, I'm sorry.
The peach, I don't know.
Oh, yeah, that's right. Y'all can't speak but one language. I'm sorry. Okay, so that takes care of that one. Next, I got to refresh. This is so weird. Okay, rationalizing. I think we went over that one. Let's go over the factoring one. That's another important one. Okay, it may seem kind of repetitious, but what is that? Well, they're asking you to multiply. So you're going to have to, let's see, you're going to have to use shortcut number 2 and then use multiplication. So this one's this one's a worker. This one you're going to have to 1 minus 2r quantity cubed. 1 minus 2r quantity cubed. So the first thing I'm going to do is I'm going to break it up into 1 minus 2r quantity squared times 1 minus 2r to the first power. Now, what am I going to do with that first side, the left side? What is that?
Foil it.
Shortcut number what? 2. Which is 1 minus 4r plus 4r squared times, oh, I'm sorry, some of y'all might be doing the reverse, might be doing the FOIL. I'll wait for y'all. Anybody doing the FOIL method? You shouldn't have to, you should go to the shortcuts, because on a factoring test, or if you got a lot of factoring or a lot of multiplying, the shortcuts are the way to go, because it takes too long to do the FOIL method. And then 1 minus 2r. Now you have to rely on the old what law? Starts with a D.
Distribution.
Yeah, exactly. You got to distribute. There's no way to do this one unless, no, I was going to say, so it could be shortcut number 3, but it's not. So I'll do the first one for you. I'll multiply everything times 1. 1 minus 4r plus 4r squared. And then what? Well, negative 2 times 1 is negative 2r. Negative 2 times 4r, negative 2r times negative 4r is positive what? 8r squared. Volume, don't forget the volume, okay? And then 4r squared minus 2r is minus what? 8r cubed. Good. Thank you, one person out of 30. I appreciate it. Appreciate the interaction, Easley and Pendleton. All right. So, is there anything I can combine?
Negative 4r and negative 2r.
Good. Thank you. Negative 6r.
You're welcome. Here we go.
All right. 4 plus 8 is 12r squared. And negative 8r cubed, and check our answer. And you feel good about yourself. Can't hear you.
Why did you cross out more?
I'm adding them together. So 1 doesn't go with anything, so you just bring it down.
Oh.
And then the 6r is negative 4r and 2. You're just combining like terms.
Now, do they like you to put the cube squared and then just
Yeah, put it in ascending order, because I don't know about WebAssign, because WebAssign is so user unfriendly that you might want to put it in descending order, because it looks like to me that's the way you want it. Did anybody type it in ascending order, and did it I don't know if it gave
I only had one like that, and
Uh,
I just put it from cube to
yeah,
squared.
you want to put it in descending order, because that's normal. That's a norm in algebraic problems, to put it in descending order. Kind of like, what do you do with fractions? Always do with fractions.
Wait, Mr. Hubert,
Yeah, you always reduce them. Yeah.
you foiled the negative 2r into it, but you didn't foil the 1 into it? Why was that?
Okay, what do you? I didn't use the FOIL method in any of this. Where are you talking about the FOIL method?
On the third, you have the 1 minus 2r. After you fold, well, you did 1 minus 2r, then you fold it out. and
Okay,
made 1
I know
minus
what you're
4.
asking. Okay,
Yeah.
hold on. This is shortcut number 2 with the minus symbol. Okay, that's how I did that. I just brought this down, and here I used the distributive law because this is a trinomial and this is a what? A binomial. So you can't use the FOIL method. So what I did is I multiplied the 1 by all of this, and I got, hold on, I got this.
Yeah, okay.
Okay, that's the 1. And then I multiplied the negative 2r over, and that's the distributive law. And I got, hold on, I got this.
Yeah.
And then I combine like terms. But you cannot use the FOIL method at this point. You cannot use FOIL, pronounce it however you like, the redneck way or the perfect way. I choose not to pronounce either. FOIL method cannot be used here because it's a binomial and a trinomial. And the only way you can, two monomials, a binomial, trinomial, polynomial times another polynomial that's not a binomial, you have to use the distributive law. Okay. Comprende?
What?
I'm sorry. Do you understand?
Yes.
Okay. Yes. Oh, me. People I have to deal with. All right. So let's move down. There's another one down here. Okay. We've done use substitution, have we not?
Yes.
But since it is important in calculus, especially with derivatives, I'm going to go over it again. All right. Here, we've got u is equal to 2x plus 1. If I make u equal to 2x plus 1, then I have u squared plus 10u plus 24. And then y'all can use the reverse FOIL. And the reason I would use the reverse FOIL, besides completing the square, do you use a hammer to put in a Phillips head screw? No. Because you'll run the threads will be useless. You'll just be able to pull that screw out because the threads will be damaged and the wood will be spread out larger than the threads. So you can't use a hammer. Completing the square is a tool that you use predominantly when you're graphing or finding either the vertex or the what? X-intercepts. This problem is not designed. This is a Phillips head screw where completing the square is a hammer. So we use reverse FOIL because it's substitution and it works a little bit easier than beating that screw with a hammer. All right? So, u, and 6 and 6 and 4 will give us, and I'm skipping the step because most of y'all should know how to get to 24. I'm going to put a 4 here and a 6 here. This one tells us that the biggest number has to be positive, so that's a 6. This right here tells us what? Like signs, so therefore that's a plus. Now you have your answer, but it's in terms of u. It needs to be in terms of what? It needs to be in terms of x. So you take your u and you plug it back in. 2x plus 1, I'm going to put that in a little set of parentheses, plus 4, and 2x plus 1 plus 6. And now you're in pre-algebra mode, and that's going to give you 2x plus what?
5.
Plus 5, Hubert. And 2x plus what?
7.
There you go. And that's your answer. Question. You will see those on the test. Why? Because I'm trying to get you to remember U substitution. Because it's called the same thing in derivatives. U substitution. Same thing in antiderivatives. U substitution. And if you notice, when I go over one of these problems, I usually give you an indication, the scale of its importance. 0 to 10, this is about an 8 or a 9. Completing the square is about a 21. Rationalizing the denominator, 21. Whatever else we've gone over. Factoring, it's a big number. Whereas the inflection points, the convergence, the limit that's a 1 or a 2. That's just thinking out of the box. All right. Take a half a step till the wall. Do you reach the wall? No. That's thinking out of the box. So that's about a 1 or a 2. When we get into the limits, the algebra is going to be secondary. The thinking out of the box is going to be primary. I'll be talking to you more about that when we get into the limits and thinking that convergence. And then when we get into the calculus, you'll put the two together. All right, next.
Hey, Hubert.
Yeah.
I know we're not supposed to ask about the test in class, but I just wanted to ask if it'll be kind of like how it was on My Labs Plus, where you put it in
Yes.
for like a couple days.
Colby asked that same question, and it's going to be kind of like that. I do give in-class test too, so don't forget that. The in-class test will be put in there also, but the online test, one of the reasons I give the online test also is because most of the time you go to another school, you're going to have in-class tests, or sometimes you're going to have online tests, so that's why I give both. The schedule right now I see us Tuesday finishing up with the two sections of the out of the box thinking. I think it's your last 2 or 3 sections, your models. I think we're going to be going over those, which I don't think are very difficult. And then I foresee us either going over a pretest Tuesday or Thursday. At that time, I tell you about the test. I tell you what kind of questions I put on the test. You get to see the pretest, and you get to see the bonus, the syllabus questions I put on the test, the handout questions I put on the test. You get an idea of how to take the test, what it looks like, and then after that, I put the due dates on it. I put the due dates on the homework, and then you're ready to go. And of course, if you haven't done any of the homework, then there's a problem. You're going to try to get all that homework done, and then you're going to call me and say that you had 5 dead grandmothers and all this, and I'm not going to reply. And then you're going to try to send me questions, and then you're going to say you're not ready for the test, and I'm not going to reply. And you're going to probably not get a good grade. All right? So if you're one of those people, then I'm sorry. You've had 3 weeks to do this. So I know I'm talking. Yeah. If
you don't confuse AM and PM, that helps too.
Yeah, you don't. Sometimes I do that. Yeah. But anyway, and this, like I say, I'm going to go over extra this test because this is the first time some of y'all have taken a test in WebAssign. So, and it's not like My Labs Plus. Like I said, it's comparing a Rolex to a Mickey Mouse. So we're just going to have to work with each other, and that'll probably be Thursday. So you're probably talking about a test between Thursday and Thursday of next week, the next week coming on, Thursday of next week to the next Thursday. But that's if everything goes fine. But you better start sending questions on those last 3 sections if you have them. All right. Now let's go back to the unanswered. I'm going to take this and did I go back? Where is it? Move to answered. And move to answered, and then I have to refresh. And let's see, I'm going down. I think we've done, what's 1.8? All right, I'm going to let you do that one. This is one we have not covered. We've covered 2 logs, but this is one we have not covered, so do it. If you can't do it, consider yourself what? A failure. Good. Good. At least y'all are learning something in this class. For those of you that can't see it, it's log base 4 of x plus 1. I'll write it up here. Log base 4 of x plus 1 minus log base 4 of x minus 1, and that's equal to what? 2. Now, I do realize that I could copy and paste these over into the whiteboard. The only reason I don't do that is because it takes too long. So y'all will get over it. If you need to, take some medication, but I think y'all will get over it. It's just with that, it's easier to do with, you have more space with the MyLabs Plus because it gives you more of a page, but WebAssign doesn't, so I'm not going to go through and copy and paste each one. All right, so does anybody remember their logarithms and what to do with a logarithm first? Not the definition. We're not ready for the definition yet, but we went over the definition the other day. So what do you do with a logarithm if it's all expanded out?
Oh.
I just gave you a cue. I just gave you a clue.
The quotient rule.
Good. Okay, you use the quotient rule not to expand, but to what?
Contract.
Simplify. Okay, you call it contract. I don't like using that word, but to bring it in, to rewrite it. All right. So that right here tells us the quotient rule that we can rewrite this as log base 4 of what? Parentheses x plus 1 divided by what? X minus 1 is equal to 2. Now, do the next step. Now, we did one like this the other day when we were going over logarithms. For those of you that wasn't here that day and you didn't look at the video because it's a lot of work to get on the internet and go to YouTube and click on your class, and it's a lot of work. So I realized that, with all that work pushing those buttons, it's kind of hard. But anyway, if you go to YouTube, I told you this when we were going over the logarithms. Just pull up definition of a logarithm.
How about that?
And when you pull up definition of a logarithm, you're probably going to have plenty of other things that you can actually, and there they are. And you can pull them up, but the reason I pull it up is because some people, here's one right here. There it is. And log base b of x is equal to y. Now, a lot of times you're going to see log base a of x is equal to y. A to the y is equal to x. You need to pick one and run with it. I use log base a, but you can use log base b if you want to. There's probably a log base a up here somewhere. Here it is. See, there's log base a, but they changed this. Let's see, here's one. That's just a question, but I'm trying to find the whole. Here's one. It's got it written both ways. But they changed this to z. So however you want to learn it. The whole point is I'm just going to take my handy dandy snipping tool. Doing this for a reason, guys. Just bear with me. Take the snipping tool. This is what I don't like to do because it takes so long, but I'm doing it for a reason. Take that, save it as whatever, and then I'm going to bring it in on the board. I can't bring it in. I'll bring it in on the whiteboard then. There's the whiteboard. We'll bring that in, and let's go ahead and bring it in as a picture, and there it is. Okay, bring that up, and somebody's going to have to give me because I'm not going back and finding it, but I'm going to show you how to use. Now, for those of you that wasn't in class the other day, and like I said, didn't go through the strenuous task of hitting a couple of buttons, that's the definition of a logarithm. It's written two different ways. That's the way I don't write either one of those ways. I write it as y is equal to log base a of x is equal to a to the y is equal to x. And you need to put little arrows here. That way you know it can go either way. Now our question said log base 4, y'all help me out, x minus 1 over x plus 1, or vice versa. Which one was it?
X plus 1 over x minus 1.
Okay. Equals what, 2 or 4?
2.
2.
X minus 1 is equal to 2. So you've got it in this form right here. So everybody go ahead and put it in there, and then find out your x, your y, and your x, y, and a, and then work it out algebraically. Because you're changing basically this from a logarithm equation to a what? To an exponential equation. And all of us are more familiar with exponents, because all logs are exponents on steroids, pretty much. All right, so you take 2, no coughing in class. Cough again, I had to throw you out. Log base 4 of x plus 1 over x minus 1. And that's everything you need. So you take your handy dandy technological highlighter, and I'm going to take the yellow, and I'm going to make a yellow mark here. And I'm going to take the aquamarine. I love the aquamarine. Okay. What movie does that come from?
Forrest Gump? I'm just taking a shot in the dark.
I just love me some aquamarine.
That sounds like something Forrest Gump would say.
No, it comes from the Lone Ranger.
Hmm.
Remember when the guy's in the barn and the woman's in there screaming, and he said, I just love me some aquamarine. The guy dresses up in dresses and stuff. It's kind of crazy. Lone Ranger was a pretty stupid movie anyway.
I try not to drink it too much.
Nobody saw it. Okay. Anyway, it wasn't a very good movie. All right. And what is this right here? What is your x plus 1? What is that? What is x plus 1 over x minus 1 or vice versa? What is that? Is it x, y, q? What is it?
X.
It's x. So now plug and chug. What is A?
A is 4.
What is y?
2.
Equal to x plus 1. What y'all laughing about? What's so dang funny? I'm going to have to throw you out of the room if you don't share. Y'all laughing at my plug and chug, ain't you? I don't know why y'all laugh at that. I grew up in math courses, and all the way to Clemson, the teacher always said plug and chug. I don't understand why people laugh at that. Y'all never heard a math teacher say plug and chug?
Nope.
Except you.
Except for me. You must be from y'all must be from California or something.
They said plug and chug.
Y'all never hear stuff like that. Plug and chug.
Greenbow, Alabama.
Plug and chug.
You plug in the numbers or you plug in the values and you chug out the what? Algebra or the arithmetic. Either one.
You have it.
Okay, forget it. Just forget it. I don't know. Substitute. We're going to substitute in the values and we're going to do the operations. How about that? Is that better? 4 squared is what? Now what?
Multiply
Multiply
x
both
minus
sides.
1.
Multiply both sides by x minus 1. So I'm going to take my handy dandy red pen and I'm going to multiply this side by x minus 1. I'm going to multiply this side by x minus 1. And when I do that, that cancels. That's what you wanted to do. And that gives you 16x. We're going to distribute this 16. I'm kind of skipping a step here. 16x minus 16 is equal to x plus what? 1. Now we're going to take this smallest bucket, and we're going to bring it over here. So that's going to be 15x. Take this negative 16 across the river, and it becomes positive 16. So our answer is what?
17.
16. How'd you feel to be whispered? I mean, you like that? I'll whisper the whole class if you want me to. Y'all need to chill out. All right, 17 over 15. Anybody got a question on this one? Is this an important question? Yes. Anything with a logarithm is important because you're going to see it again. Because all your business graphs are exponentials or they are logarithmic, either one, because they're in the first quadrant. Can you have a logarithmic, a regular, normal logarithmic function in the third or fourth quadrant? You can, but you can't usually take the log of a negative number. So that's why predominantly you see a lot of exponentials and you see a lot of logarithmics in the business and marketing because of the first quadrant. And now you know in that function that we just did right here that x is going to be 1.1 something. Okay? Now, make sure you read the directions on the test and the homework because they may ask you to type that in as a decimal. I don't know. But you can go back to the question and see. Let's go back and let's look at the question after I get rid of this. There's the question. It doesn't say. Okay. I guess that's correct. Did anybody type in a decimal on this type question? Will it take a decimal? I doubt this one will. My math labs probably would, but this one's... Shut up, you. Okay. I didn't move that one back. Sorry. Question. I think I did. Did we do? We did. Okay. Now, difference quotient, very important.
Yeah.
Very important.
5 or 6 questions.
Okay. That one was the one we just did, I believe. 1.8, I think. Oh, I have to refresh it. I'm sorry. Did it move? Oh, there it is. Sorry. I'm looking. I don't know what 1.5 is. Just letting y'all know, this is not a problem with Polycom. This is a problem with WebAssign. This is not.
Refresh on WebAssign even between homeworks, like you finish.
You are kidding me.
Yeah, you finish a section and then you try to click on the next one and it takes forever to load, and then you refresh it and it come right up.
All right, this is a graphing. We did this one. This is a graphing equation. I tell you with all sincerity to do this on your calculator. But we'll go ahead and finish it. We'll go ahead. I don't think we did interpolation or extrapolation, but I'll tell you the difference between the two, and you should be able to do more with it. This interpolation is when you take a graph and you predict within the realms of the graph. Let's say this is your graph, whether it be a curve or whether it be a straight line. If interpolation, just remember inside, it's inside these two spots. You find a point and you call it 4, 2, or $4 million, 4 million units, and you make $2 million. All All right, whatever the case may be. That's interpolation. Interpolation can also be the square root of 8. Well, the square root of 8 is between what? The square root of 4 and the square root of what? 9. Square root of 9 is 3. Square root of 4 is 2. So this is going to be around 2 point what? 2.9. That is interpolation. Usually, remember, interpolation is between two what? Two known numbers. So 4 and 2, or the square root of 4, the square root of 9, 2 and 4, 3. You look inside interpolation. What is extrapolation? Outside. So how do you do that? Well, extrapolation is when you go outside the points. Let's say you have 2 points right here, and this is, let's see, years since 2000. So this is 2005, 6, 7, 8, 9, 10, 11, and so on. And they ask you, but you only got data to 9 years, 2009. Extrapolation is when you take the formula that you calculate, which is right here, and you plug in a value, which I'm going to plug in 11, and 11 will give us a predicted value right there. Let's say 11 units at, I don't know, $15 million, okay? So there is, and what you did, just remember, EX, you extend the line. You extend it, but you don't, are you 100% sure? No, nothing's 100%. When you predict, it's not 100%, but you can give a good indication. Okay? Okay, remember what I said about the, I hope you're using the calculators on those phones. I hope you're not texting while I'm teaching. Remember, I treat you like what? I want to be treated. Remember, if you come up to me and ask me a question and I start texting, what is that? That's rude. That's disrespectful. So if I won't do it to you, why should you do it to me? Okay, just because you're, let's see, how far is Pendleton? 15 miles away? Just because you're 15 miles away and 30 miles away and easily doesn't mean I can't see you. Okay? All right. And don't put it between your legs because that just insults my intelligence. Next time, that's a shot across the bow. Just warning you, next time I'm going to call you out, and I don't want to do that. Anybody got a question on extrapolation or interpolation?
Extrapolation's always just like, it's like predicting, pretty much, right?
And interpolation is finding the middle of the middle. In other words, inside. Interior. Remember, interpolation is interior, extrapolation is extending. And whenever they ask you to put in a point into a formula, most of the time it's going to be what? Extrapolation. Because if it was interpolation, they would have already given you the point because it's inside the points. Okay? Question on that one?
No.
Okay, thank you for the interaction, one person. I appreciate that.
When will you use interpolation? Because on that chart right there, they already give you the points, right? So
Yeah, but they're asking you, look, they're asking
you the rate of change if it was continue going on.
Yes, the rate of
That's
change.
why I get why it's extra, what you call it, explanation.
Yeah, no, look, it says that's the slope. Okay, this right here, we covered that the other day. This is the slope. See, 3.343?
Yeah.
That's the slope. That's rate of change slope.
Yeah.
But don't tell some teachers that, or they go into cardio arrest, whatever it's called. Use the model to what?
Estimate.
Estimate is the key word. When you see the word estimate, that means they want you to predict. The number of North American business emails is what?
2015.
Okay, how long is 2015 from 2000? 15. So what are you going to do with that 15? I'll plug it in for X, crank out a number, and that's your prediction. So you used extrapolation because what does this only go to? This only goes to what? So your last point is at 10. They're asking you to predict at 15.
So you would use interpolation if they asked you the change from
Yeah.
2000 to 2010?
Yeah.
Because it's on the graph?
Yes.
Okay, that's what
That's
I'm trying to figure
interpolation.
out.
But that's a good question, whether it's, yeah. They ask you anything that's within the chart, that's interpolation. If you ask anything, they could ask you this. What is the growth 6 months after 2009? Would that be interpolation or would that be extrapolation?
Interpolation.
Interpolation is inside the points. It's inside 2001 or whatever in 2010. So they can ask you a question that you don't know within the 2 points. What is 3 months into the interpolation? Well, instead of 9, you would do 9.3 or 9.4 or 9.5. You would plug 9.5 in, or you would use your trace feature or your, what is it called, table? You would use your table feature in Excel or your calculator. That's interpolation. Don't y'all feel smart?
Yep.
Use these big words now? Okay. Just don't use them when they're not supposed to be used, because then you sound like what?
Douchebag.
Yeah. Yeah, pretty much. Either one. You said the word and you said the word too. So both of you said it. I'll have to censor that. But anyway, I'm just kidding. Okay, so that's that one. Let me move that to answered. Archaic refresh. I'm looking because I think I've covered pretty much everything. Can y'all help me out? Let's see. Rationalizing, I think we did those. I'd like to find a good rationalizing, one that has, okay, there we go. There's one right there you'll see on the test. Both of these. Let's do this one. I don't know if we've done it or not. But that one right there you'll see on the test. I know we did a numerator. Did we do a numerator? I think we did.
I think we did at least one of them.
Yeah, but this one, I don't think we've done one like this. And this is the one you're going to see on the test probably. So we've got 1 over 14 minus the square root of 195. Now, what is the C word we're going to use to rationalize numerator or denominator? C word. C-O-N.
Con.
Yeah, that's right.
Conjugate.
Conjugate. You're going to conjugate. You're going to use the conjugate. What is the conjugate? The opposite what? O-P-E-R-A. Operation. Good, class. What's the opposite of 14 minus 195?
What are you saying? I can't hear that.
14 plus 195, Hubert.
Yes.
I appreciate y'all interacting with me today. Now, what will that give you in the denominator or the numerator, depending on what the directions are asking? What will it give you 100% of the time? Shortcut number 3. Good, class. And that's right here. Shortcut number 3. So that's going to give us in the bottom 14 squared minus square root of 195 squared. Do we really care that much about the numerator if we're rationalizing the denominator? No. Most you're going to do is distribute. You might, do, but the most you're going to do in the numerator, if you're doing the denominator, is distribute. 1 times this is 14 plus the square root of 195. Now, what's 14 squared? 190 what? 96. That's right. And what's the square root of 195 squared?
195.
Good job. Oh my gosh, get your calculators out. We need to do this math. What's 196 minus 195? 1. So your answer is your numerator right there. Now you've got a numerator. We've rationalized the numerator in your notes. We've rationalized the denominator in your notes, and we've rationalized the fourth root, the fifth root, the seventh root in your notes. So I think we've covered rationalizing real good. Does anybody have a question about anything that we're going over? Just we did one. Let's see. This one says the denominator. We've done one. We just did that one. Here's another good one. That's rationalizing the numerator. Let's do that one. That one will discourage you and get you to quit. Let's do that one. Yeah, most of you will quit on this one. Why? Just too much writing. I can't do that. It's too much. Y'all haven't ever said that? No, not at all. So I'm going to let y'all give y'all a minute to try to start it off and see what you get. That doesn't mean have a conversation. That means pencil, paper, you know. See, how many people we got at Pendleton? 1, 2, 3, 4, 5, 6, 7, 8. No? 1, 5, 6, 7, 8, 9. Is there 9 at Pendleton? Just want to make sure there's nobody sitting beside.
There's 10. She's just in, I think she went to the restroom.
Oh, okay. Yeah, the laptop. Okay. There's 10 there, so that one's full. And then at Easley, 1, 2, 3, 4. Is there only 4 there today? Where's Mr. Fell?
Yeah, I'm waiting on him to show up. He normally does around 45 minutes in.
I don't know. He's probably in a ditch somewhere. And let's see. 1, 2, 3, 4, 5, 6, 7. 7 out of 8. So I think we've got everybody here today, except for a couple in Pendleton. I'll call the roll after I'm not going to record calling the roll, so I'll cut it off after.
Can you write the problem bigger?
Oh, I'm sorry, yes.
Little blind.
Have y'all got y'all's maximized? Or that's one thing I don't like about WebAssign.
Yeah, it doesn't.
It's so
get
small.
big.
Minus 8 minus square root.
Man, the letters are hard to read sometimes.
I'm sorry, say again. What'd you say?
Marshall thought that a Z
WebAssign.
was an approximate equal sign one time.
I did too.
Yeah.
I thought that was the approximate equals.
Yeah, that
He was
can
texting
happen.
me, and it was.
That can happen in MyLabs Plus. There's some problems in MyLabs Plus that look like that too. So it's not the Polycom and it's not the student. It's the actual program on that.
Where's the approximate
no,
equal
I was
sign? I was
looking-
like, that's a Z.
I did that last night, and I was like, "Where's that?"
All right. Now, what's the conjugate of this radical minus this radical?
On my laptop.
Plus
I was like, what the
radical.
hell?
So you're going to set it up. I'm going to have to write small here. The square root of x plus h minus 8 minus the square root of x minus 8, and I'm going to write over h, and I'm going to multiply, and I'm going to color it red. Square root of x plus h minus 8 plus square root of x minus 8 over that same thing. X plus h minus 8 plus square root of x minus 8. Now do your shortcut number 3 on the top, and the best way to do it is I'm going to take a blue pen, and I'm going to say, just put a big set of parentheses squared minus a big set of parentheses squared, and just plug this one in. That's a. X plus h minus 8. Yeah, plug and chug. Everybody do their laughing now. And then x minus 8 square root all over h, and again, that's going to be basically just put this in parentheses, square root of x plus h minus 8 plus square root of x minus 8. Okay? So again, when they ask you to rationalize the numerator, the denominator is going to be secondary. When do you do this? You do this when you're talking about limits and calculus, mostly limits. When you're algebraically solving for a limit, sometimes you have to rationalize the numerator, okay? Because you can't take the square root of a negative. If you took the square root of a negative in the denominator, what would it give you? Does not exist, okay? And you can't do that. So that's why sometimes, or you have something that'll give you 0 in the denominator, like x minus 1, all right? If you plug in 1, the square root of x minus, if you have x minus 1 in the denominator, and you plug in 1, what do you get in the denominator? Okay, so there's some questions when you get an algebraic limit and you have something in the denominator that's not right, you have to rationalize either the denominator or the numerator, depending on what it's asking. And that's use this. So, what happens to the squares and the square roots? They go out. And that's going to leave you with x plus h minus h. Now be careful here what you have to do here. You've got to change the sign of this x. That's a negative x plus what?
8.
Negative x plus 8. And that will change a lot of things. And I've just put a squiggle line here. And that squiggle line means this does not change. The denominator just carries over. Okay? And what happens to the 8s?
They cancel.
X's.
Cancel out.
And what happens to the h's? Right here. Let me do this in red. What happens to this h and this h?
They cancel out. Cancel.
And anything minus itself is 1. So 1 over, there's your answer. That's what you get. 1 over squiggle. And the squiggle representing that denominator that just goes over. On a scale from 1 to 10, these two that we just did are 10s as far as being on the test.
See, but now I think 10's not that important because you've been saying 15.
Okay,
20.
15. All right, it's a 15. Questions? Right, complaint. Okay. All right, now I want to talk to y'all for a second before I stop the recording. Those people that hadn't had algebra in 2 years, you said you didn't have it in 2 years. Some of y'all, 2 semesters, 2 years, same thing. How you feel now?
Feel good.
Getting there, yeah.
Okay. Those of you that didn't have a good experience in either 110 or 109, how you feeling? Okay, nobody's going to say anything. Those of you that had an exceptional 109 teacher, how do you feel? Lost.
Good.
Great.
Okay. All right. The whole point is everybody should be, by Thursday, everybody should be on the same sheet of what? Music. Because when I start covering calculus, it's going to be section by section. It's not going to be me giving you a bunch of homework and you doing it. We're going to be covering section by section. And hopefully, since everybody is telling me they're on the same sheet of music, if they're not texting on their phone, if everybody's telling me that they're on the same sheet of music, then that means that I can start calculus with everybody feeling good about themselves. Right? Okay. All right, so what do y'all need to be doing this weekend? I just extended the homework because I can't leave it open on this this, whatever you want to call it, WebAssign. So what I want everybody to do is work on their homework this weekend, try to finish it up. I will leave Tuesday open for any new questions. I'm going to get rid of all these questions, and I'm going to let you send in more if you have them. If not, what are we going to go over Thursday? Or what's today? Tuesday? What are we going to go over? We're going to go over the test, the pre-test, and then I'm going to assign it, and then you're going to be responsible for it. That means Thursday, we're going to go over calculus. We're going to start calculus. If not, then we'll have the test, pre-test Thursday if y'all send in questions. So, but if y'all keep sending in the same questions, I'm going to say they're just stalling, because I know what you do. I know what your plans are if you do that. Okay? Anybody got questions for me?
No, sir.
Okay, I'm going to stop. I got to call the roll, and I'm not going to record the roll because that would be kind of redundant. So I'm going to stop the recording.